Um, as far as the probe theory is concerned, it is broadly classified into collisional and collisionless. Now, if we take an IV Cara for a high pressure plasma, then to extract the parameters we have to use a collisional probe theory. And if we take an IV Cara for a low pressure plasma, we can use a collisionless theory. Now, simple rule of thumb is, if the debye length lambda d is smaller when compared to the mean free path, then we can use a collisionless probe theory. If the debye length is greater than the mean free path, then we have to use the collisional theory. So, mean free path, which is a function of pressure, defines whether we have to use a collisionless theory or a collisional theory. So, pressure decides which theory we have to use. And as far as our case is concerned, 500 millibar is close to 1 bar. It certainly comes under the high pressure plasma classification. So we have to use collisional probe theory because their collision dominates, and definitely collisionless theory does not work there. Now, this is the equation bottom one for collisionless theory that we traditionally use for low pressure plasmas, and the top one is actually the collisional theory. Now, the main difference between these two equations is this mu I, mobility of ion. Now, this expression is used to estimate the number density of ions in plasma. Now, what I did is we used a probe of length 1.5 mm and diameter 0.25 mm. For this probe dimension, we took a Cara for 0.5 millibar pressure condition, and while taking the Cara had a 20 microampere ion saturation current, and electron temperature was found to be 13 eV. Now, these values were plugged into this collisionless probe theory equation to estimate Ni. I sat is 20 microampere. Electron temperature 13 eV, area of the probe is estimated from this dimension. While plugging in these values, I found the number density to be 1.7 10 to the power 16 per meter cube. Whereas, while plugging in the same value into this equation, which is the equation for collisional probe theory, ISAT is 20 microampere, length is 1.5 mm, probe radius is taken from this value, K is Boltzmann's constant, mu I is the mobility, which is 1.5 10 to the power minus 4 meter square per volt second. It's an experimental result, mobility of argon, ion in argon, and Te plus Ti. For non-equilibrium plasmas, we can assume Te very large compared to Ta, so Te plus Ta can be assumed to be Te, and Te is taken to be 13 eV. Now, while plugging in the same values into this equation, it gave out a value which is 1.4 into 10 to the power 19 per meter cube, which is way much larger when compared to the number density got for collisionless theory. So, same values, when we plug into two different theory, they are giving out two different results which are highly different from each other. 3 order difference is there. So, what I am trying to say is, since our chamber pressure is close to the atmospheric pressure, using a collision-less probe theory, which is this is the equation which is used in the MATLAB code that I am actually using. So using this theory for our pressure condition will definitely give incorrect value. So we have to use the collisional probe theory equation in order to get some valid results. That's what I'm feeling. Otherwise, we are making a huge blunder. 3-order difference is a huge difference, 1,000 times. So I think we have to redefine the number density equation with the collisional theory equation.